The Moivre's theorem, example 1. Write 1 plus root 3i in polar form, and hence find the value of this number to the power of 9. Let's draw a sketch of 1 plus root 3i first. We know its real value is 1 and its imaginary part is root 3i. Root 3 is roughly 1.7. We see that this number appears in the first quadrant of the Argand diagram. You could get the modulus of the number using Pythagoras' theorem. So the square on one side is 1, the square on the other side is 3, 3 and 1 is 4, the square in the hypotenuse is 4, and the square root of 4 is 2. We can see that the modulus is 2. We could also use the modulus formula to find this. In other words, the modulus R is equal to the square root of 1 squared plus root 3 squared, which is equal to the square root of 4, which is equal to 2. Next, we need to work out the argument theta. This is the angle that the number makes with the positive sense of the real axis. We can see from the diagram that theta is equal to tan inverse root 3 over 1. The tan of root 3 over 1, or root 3, is pi over 3, or 60 degrees. Put your calculator in radians to get this answer. So in polar form, we'd express I plus root 3i in terms of its modulus and argument. It becomes 2 times the cosine of pi over 3 plus I sine pi over 3. This is the first answer. In the second part of the question, we're asked to raise this to the power of 9. To do this, we're going to use the Moivre's theorem. The Moivre's theorem says that if you raise a number to the power of 9, you raise the modulus to that power and multiply the argument by the power. So we want to raise 1 plus root 3i to the power of 9. So this becomes 2 to the power of 9 multiplied by CIS of the angle pi over 3, which is multiplied by 9. 2 to the power of 9 is 512. And we want to work out cosine of 3 pi plus I sine 3 pi. Using the calculator, we see that the cosine of 3 pi is -1. So we have 512 times -1 plus I by the sine of 3 pi, which is 0. So we have 0i. When we multiply this out, we get -512.